So these ones are on solving absolute value equations. Just to remind you that we talked about absolute value before, but when you do the absolute value of a number, it's either going to equal 0 or a positive number. But if you try to take the absolute value of a number, you're never going to get a negative answer. So just to remind you of that. So when you're solving an absolute value equation, there is no such thing as the distributive property. You have to get the absolute value by itself and then apply the rule for absolute value. So in this case, if I want to get the absolute value by itself, I end up having to divide by the -4. And so I get the absolute value of x equals 8. Since that is a positive number, you're actually going to end up getting two solutions because the absolute value of 8 is 8. 8 is 8 places from 0, but so is the absolute value of a -8. So it'll tell you in the directions that if you have more than one answer, separate them with a comma because you're going to get two solutions if this is a positive number here. So on number 2, if I want to get the absolute value by itself, the first thing I'm going to do is add the 20. And so the absolute value of x would equal 7. So what values are 7 places from 0 on the number line? Both 7 and -7. Sneak this bottom one in here. On number 3, if I'm going to solve that one for x, I would divide it by -5, and you'd have the absolute value of x equals -6. So since absolute value by definition is a distance, you can't be -6 places from something. In this case, you're just going to pick over to the side the little box that says no solution, because the absolute value of nothing is going to give you an answer of -6. So normally when you work with absolute values, you're going to get two answers. Occasionally you get one answer if you just have equals 0 or you have no solution. Same thing here then. If I have the absolute value of something equals 9, I'm going to have what Alex calls two cases, two separate problems. Either the -2u minus 9 equals the positive 9, it's 9 places away from 0, or the -2u minus 9 could equal the -9. Both 9 and -9 are 9 places from 0. So I'm going to have two problems, and then I just solve my two problems like I normally solve any other equation. So adding 9, -2u equals 18, dividing by -2, hey, u happens to be -9. Here I would add my 9, -2u would equal 0, and 0 divided by -2 is still 0. So when you put your answer in, you're just going to separate them with a comma and say, oh, I've got two answers, either -9 or 0 would make that a true statement. So on number 5, same thing would hold true. That's equal to a positive 10, so you're going to write down two separate problems. Either the -4w plus 6 could equal the 10, or -4w plus 6 might equal the -10. So if I'm going to solve the first one, what would I do? Subtract my 6, so -4w equals 4, then I would divide by -4, so w equals -1, right? On the second one, same two steps. If I subtract my 6, -4w would equal -16, and then if I divide, w equals +4. So -1 and +4 are both solutions to that equation. Now number 6, you'll see that this absolute value equals -8. Hopefully right away you look at that and say, oh, my answer is going to be no solution because an absolute value can't equal a negative number. So if this is by itself and there's a negative over here, I'm just going to click on that little box that says no solution right away and there's no work to do. So 7, 8, and 9 kind of have the same kind of theory here, that either the absolute value could equal the positive, which wouldn't change any signs, or the negative, which means you'd have the opposite. So when you do your two cases, you're going to leave one side the same both times. The other side, once you'll leave it the same, the other time you do the opposite. So I would first of all say either the 2u plus 6 could equal 5u plus 9, leaving everything exactly the same as it was, just dropping the absolute values. On my other case, one side you're going to leave the same, the other side you're going to do the opposite. Doesn't really matter which way you do it. I usually leave the left side alone and do the opposite of the right side. So I would say 2u plus 6 would equal the opposite of both of those, so negative 5u minus 9. And then, of course, I solve those like I solve every other equation. So I'm going to go ahead and subtract my 5u to move it over and subtract my 6 to move that to the opposite side. So 2 minus 5 gives me negative 3u. 9 minus 6 is 3. And when I divide, negative 1 is one of my answers. Now, sometimes we will get fraction answers, and sometimes we'll get ones that don't work out. But in this case, I've got one answer doing the other one. I am going to add my 5u and subtract my 6. So 7u equals negative 15. Here I've got a fraction. And so negative 15 sevenths is going to be my second answer. So negative 1, positive 15 sevenths. So in these ones where you have absolute values on both sides, you're always going to do two cases, they'll call them, two separate problems to solve. So number 8, again, my first problem, just the exact same problem without the absolute values. So negative 4v minus 5 equals negative 7v plus 5. My other problem, I'm going to leave the left side the same, so negative 4v minus 5. I'm going to do the opposite of the right side, so what should I have on the right side? Positive 7v and a negative 5, right? Change both of those two sides. So, solving that, I am going to go ahead and add my 7v and add my 5, and I would get 3v equals 10, which means v equals 10/3, right? On my other one, I'm going to subtract my 7v and add my 5, so I would get negative 11v equals 0, right? And 0 divided by negative 11 is still 0. So 10/3 and 0 would be my two answers for that. So number 9, if I'm going to write down my two equations, my first equation would be 2x minus 7 equals negative 2x plus 3. My second equation would be 2x minus 3, right? So 2x minus 7 equals a positive 2x and a minus 3. So solving my first one, I'm going to add my 2x and add my 7, and so I get 4x equals 10, and so when I divide by 4 and simplify my answer, x is going to equal 5 over 2. On my second one, I'm going to minus my 2x and add my 7, and what am I going to get? 0x equals 4. And what happens when you do 4 divided by 0? It's not 0. It's a math error. It's undefined. So in other words, this would give you a no solution. So in this case, instead of getting 2 answers, you're just going to have the 1 answer. You'll just enter in the 5 halves that we got in the first problem. So that will happen on occasion, where you have one where you get 0 x's and get something that's undefined. Set builder and interval notation is in that next part of the pie. I don't know why they put it in this chapter. To me, it'd make more sense to be in the next chapter, but they do. So, set builder notation is just a different way, and interval notation, a different way of writing what this says in a more compact form. So if you take calculus and you have to write stuff as compactly and in nice note-taking things, it's a different way to write it than this is. When I'm graphing it, if the equal sign is there, I use the filled in dot. If there's not an equal sign, I use an open circle. So this is basically read x such that, I'm going to assign the rule. -2 is less than or equal to x, which is less than 0. So on my number line, I have a filled in circle at the -2. I have an open circle on the 0 because I'm going up to that point but not touching it. The x is in between. And we already did some graphing, so maybe you already know how to do that part. In interval notation, if you are equal to the value, you use the bracket. So if you see that filled in dot, you're touching that point, you use a bracket. If you're not touching it, you're going to use a parenthesis. So in this case, my interval, as I read from left to right, they will always go from left to right, is that I'm going from -2 to 0. I'm going to have a bracket on the -2 end saying I'm including that number. I'm going to have a parenthesis on the 0 end. I'm not including the 0. So this and this mean the exact same thing, but the second way is a more compact way of writing it. So number 11, we're graphing the set x such that 1 is less than x, which is less than 7 on the number line. So what kind of end mark should we have on the 1? We'll get to that. On the graph, we're going to put an open circle, right? On the 7, also have that open circle. We don't have any equal to bars underneath, and we're shading in between. So our interval is going from 1 to 7, and as Gavin said, we're going to have a parenthesis on the side with the 1, and we're also going to have a parenthesis on the side with the 7, because I'm not touching either end of that, right? Number 12, we're graphing x such that x is greater than -1. So this one, we're not between the two numbers, we're just keep going on and on and on. What kind of end mark do we have on the -1? Open circle. We're graphing everything going this way, which means we're going towards infinity, right? And so my interval in this case would be from what to what? And what kind of end mark are we going to have on infinity? A parenthesis also. You can never reach infinity, so you're never going to be right on infinity. So infinity will always have a parenthesis. Be careful that when you're doing one that has less than, that you start with the negative infinity and go to the number. You always go from left to right on your number line. So it would go negative infinity to whatever the end number was. The next one's union and intersection. Union, you're joining everything together in one great big long set. If something repeats, you only need to put it on your list once. Doesn't need to be in there more than once. Intersection, what do the two sets have in common? So the symbol for union looks like a U. So you'll see them do something like A union E, and that tells you you're supposed to do the union. So my union, I'm just going to make all of my numbers in one big long set. You don't have to put them in order unless you really want to put them in order. Normally I would just start and say, okay, 1, 2, 3, 4, and 6 are in my first set. I need to add a 0. I've already got the 2, I've already got the 3, but I need to add the 8. And now I've got all my numbers in there. My intersection looks like an upside down U. Sometimes they call that a cup and a cap. What do they have in common if I overlap my two sets? Well, they both have 2 and they both have a 3. If you don't happen to have an intersection, you'll use this symbol here, the empty set symbol. You don't put the empty set symbols in set symbols, it's just empty set. Some people try to do this and they count it wrong because that's not on your list. So you'll use that if there is no intersection. So number 14, they first want you to do the intersection of L and J. They like to switch them around to see if you're reading. What is the intersection of those two sets? Nothing, the empty set. And what is the union of those sets? See if I got all those things you said. Well, put them all down anyway. So, got -1, 1. I jumped to the -2, 3, 5, 6, and 8. I got them all. And sometimes they'll throw variables in there instead of numbers. What do they want first here? Union. So if I'm doing the union of my two sets, I would have A, B, I, and G, A, E, I, B, and G. And the intersection, just the I. They will have the set symbols over to the side that you can click on. You can also use the keyboard to put them in. Now they go back to the other section. Like I said, I don't know why they throw those other ones in there, but they did. Solving an inequality. We solve inequalities just like we solve equations, except if you end up multiplying or dividing by a negative, you end up reversing your inequality. 9 times out of 10 it's dividing, but on occasion we end up multiplying by a negative and we have to flip our inequality sign. So if I'm going to solve this one, first thing I'm going to do is move my 7 to the other side, so -20 is less than -5u. And on the adding and subtracting, that sign's always going to stay in the same direction. Then we'll look and say, oh, I've got to divide by a -5. Since this value, my coefficient is negative, I end up reversing my inequality. So 4 is greater than u. Now on Alex, it does let you enter it in as 4 is greater than u. Sometimes some books will make you switch it around because they like the u first. So if 4 is greater than u, then u is less than 4 would also be an appropriate answer. So on number 17, if we're going to solve that for y, we would do what? Subtract our 22, and we'd have -7y is greater than -14, and then we end up dividing by -7, and so our answer would be
y is less than 2.
y is less than 2. Again, we divided by a negative, so we ended up flipping our inequality sign. Number 18, if we're going to solve that, we're going to add the 18, and we would get 12 is greater than or equal to 2v. When we divide by 2, our answer would be 6 is greater than or equal to v, or v is less than or equal to 6. So they review that with you because then they want to move into those ones with fractions. Again, on the ones with fractions, you could do it with the fractions and you could subtract the 5/3 u and add the ones, but usually people make a lot of mistakes with fractions. So my recommendation again is to multiply by that common denominator first. Make sure you multiply it by every term, and that way you can get rid of the fractions. Here, if I have a 3, and a 6, I can use 6 for my least common denominator. Some people, I multiply them all together and use 36. Well, that works, but why use a bigger number than you need to? So I'm going to multiply each term times 6. 3 goes into 6 2 times. 2 times negative 4u would be negative 8u. Here I don't have a fraction to cancel. 6 times negative 1 is negative 6. Is greater than or equal to, 3 goes into 6, 2 times 5u would give me 10u. 6 goes into 6, 1 times 7 is 7. Now when I multiply by that common denominator, I always use a positive number, then I don't have to worry about flipping my sign. So my sign should all stay the same. That was negative, that was negative, that was positive, that was positive. Now I have an equation that's maybe easier to solve. If I want to solve that, what would you guys do first? Add the 6 to move that over here, which means I would probably in the same step subtract the 10u just to save myself some space. So negative 18u is greater than or equal to 7 plus 6, which is 13. So in this case, my coefficient's going to be negative. I'm going to divide by negative 18. So u ends up being less than or equal to negative 13/18, because I'll put that negative out in front instead of down on the bottom. So number 20, if we're going to solve that one for u, first thing I do is get rid of the fractions. What should I multiply every term by? 28. Since I have a 4 and a 7, the only thing I can do is take 4 times 7. So 28 times every one of those terms. 4 goes into 28, 7 times 3u would be 21u. Here we didn't have a fraction. 1 times 28 is still 28. Here, 28 times negative u is negative 28u. And then 7 goes into 28. 4 times negative 5 would be minus 20. And I got rid of all my fractions and made life a whole lot easier. So on this one, I'd probably add my 28u and subtract my 28. And so what would I have? $49u is greater than or equal to negative 48. He's yawning now. And so when I divide by my 49, my answer would be u is greater than or equal to negative, whoops, I better write the right way. I'm trying to switch it around on you. 48 was on top. 48/49. Again, they'll put the negative out in front instead of on the top of the fraction. So number 21, if I want to get rid of my fractions, I'm going to multiply by 18, right? That's my least common multiple of 9 and 6. So if you multiply everything times 18, what will I have?
Negative 10b minus 36 is less than or equal to 21b plus 8.
Exactly. Negative 10b minus 36 is less than or equal to 21b plus 8. So one thing some people like to do is they notice that if they move this over here, the v is going to be positive. You don't have to put the v on the left side. You can if you want to, but if you want to avoid having to flip your sign, move it so that your variable stays positive. So for fun, I'm going to add my 10v, because I can tell you guys are having so much fun, and subtract my 8. If I do that, I'm going to get
Negative 44.
is less than or equal to
31b.
31b. So that way I can divide by my positive 31 and I don't have to worry about flipping my sign. So negative 44 over 31 is less than or equal to v. And again, you can put it in that way, or if you want to switch it around so the v is first, you could put v is greater than or equal to negative 44 over 31. The next three are compound linear inequalities. Sometimes you have it all built into one. That's like having an and between them. Sometimes they'll do it two separate ones where either they'll have the word and or the word or. And means it has to be in both sets. Or means I've got two separate sets, so on my graph usually and is in the middle, or is the two outside ends of my graph. So if I have this one here, negative 12 is less than or equal to 4x plus 4 and less than 16. When I'm solving this for x, I have to subtract my 4. It's like I'm doing two separate problems, so I'm subtracting my 4 from here. I'm also subtracting my 4 from the other side. I could, in fact, write it as two separate problems if I wanted to. So negative 16 is less than or equal to 4x, which is less than 12 then. I'm then going to divide by my 4. Since that's a positive 4, I don't have to flip my signs, so negative 4 is less than or equal to x, which is less than 3. So on my negative 4, what kind of end mark am I going to have? The closed circle. And on the 3, the open one, and then I'm going to shade between my two dots. So number 23, they have this already as two separate ones because it's an or, which tells me when I'm done I'm going to be graphing my two opposite directions. But 4x plus 1 is less than or equal to negative 15. 3x minus 5 is greater than 1. And then I just solve those like I solve anything else. I'm going to minus my 1. So 4x is less than or equal to negative 16. Divide by my 4. Since that was positive, I leave my inequality. X is less than or equal to negative 4. The other side, I'm going to add my 5. 3x is greater than 6. Again, I'm dividing by a positive, so I leave my inequality, and 6 divided by 3 is 2. So, on my negative 4, I'm going to have the closed circle. On my 2, I'm going to have the open circle. I am less than the negative 4 or greater than the 2, so I end up shading those two opposite ends. And when you shade on Alex, you just really have to click anywhere on the left or the right of the dot. You don't have to drag. Just click and it'll shade that whole side of the dot. So on 24, we have 7 is less than 2x plus 5, which is less than or equal to 17. If I want to solve that one, what would I do? Minus my 5 first, so I would get 2 is less than 2x, which is less than or equal to 12, and then I'm going to divide by 2. So 1 is less than x, which is less than or equal to 6. So on my number line, I have an open circle at 1, a filled in dot at 6, and this time I'm shading between my 2 dots. I didn't put any of those that had the compound one written with an and, but if it does have an and, you should be shading between the 2 dots. Most of the and ones are already written together. So solving a decimal word problem using a 2-step linear inequality. So pretty much like the word problems we did on the previous page, this time we're going to use an inequality instead of an equal. To rent a certain meeting room, a college charges a reservation fee of $49 and an additional fee of $6.40 per hour. The math club wants to spend less than $106.60 on renting the meeting room. What are the possible amounts of time for which they could rent the meeting room? Use T for the number of hours the meeting room is rented and solve your inequality for T. So they are going to tell you what variable to use. If you try to use a different one, it'll count it wrong. So make sure you use the one they tell you to use. So we charge $49 and an additional $6.40 per hour. We're using T for the time, so $6.40 T. The math club wants to spend less, so a less than sign, $106.60. So we've translated it into our inequality, now we just have to solve it. So we're going to start by subtracting our 49. I'm going to let you subtract that for me. 106.60 minus 49 would be 50 what? 57. 40? Is that what you said? No? 57.60. All right, how about I subtract? 0.6, that's what she said. Okay, 57.6. See, there's a fan up there. I have a hard time hearing. I got to divide by my 640, so T has to be less than 9? 9. So if I rent the hall for less than 9 hours, I'm going to stay in budget. Lamar is going to rent a truck for one day. There are 2 companies he can choose from, and they have the following prices. Company A charges $93 and allows unlimited mileage. In other words, they're going to charge me $93. Doesn't matter what I do. I could drive it all over town and round in circles, or I could drive it for 1 block. I still pay $93. Company B has an initial fee of $65 and charges 80 cents for every mile driven. Use M for the number of miles driven. So what mileages will Company A charge less than Company B? I want A to be less than B again. And so I just put less than symbol in there. So if I'm going to solve this, I'm going to subtract my 65 first, and I would get 28. It's less than 0.80 M, and then I would divide by my 80 cents. So I would get 35 is less than M, or M is greater than 35 just because it makes more sense. If I drive more than 35 miles, A is going to charge less than B. There we go. So I can read that better. And the last one. For his phone service, Brian pays a monthly fee of $21. He pays an additional 4 cents per minute of use The least he has been charged in a month is $63.16. So, what would my inequality be to represent that?
21 plus 0.04 less than or
So if the least he's been charged is $63.16, that means that's the lowest number, right? So it's going to be greater than or equal to $63.16. So the least is the lowest amount. It could be more than that. And so first thing we're going to do is subtract our 21. 0.04m is going to be greater than or equal to 42.16 if I just go ahead and subtract that. And then I'm going to divide by 4 cents. So 42.16 divided by 0.04.
1054.
1,054? So m is greater than or equal to 1,054. I believe somewhere back in the review section you had a little table that had the at least, at most, and all of that stuff in there. Otherwise, just keep track as you're doing them if you have trouble with that wording.